How mysterious is the neutron star? Why is it called the universe ghost? All the substances in the world, including the atoms that make up our bodies, the air we breathe, and even the sunlight, are all made up of basic particles such as electrons, quarks, and neutrons. These particles were all created by the Big Explosion and the evolution of the universe. In this video, we will focus on neutrons. Neutrons do not carry electrons, and their quality is extremely small. As an unusual basic particle, it has too many fascinating properties. They interact with matter through only two of the four basic properties: their attraction and weak interaction. Neutrons have almost no quality. In addition, their own attraction is extremely small and can hardly be detected. Their movement speed is extremely close to the speed of light. As for their weak interaction, neutrons must be very close to other particles, such as quarks or electrons, in order to interact with them. Therefore, it is difficult to be disturbed by their weak interaction. In other words, the weak and the strong attraction to neutrons is almost zero. This means that neutrons have almost no reaction with matter and can easily pass through atoms. It's like the crosswall tree in science fiction. When we close our eyes in this short moment, there are nearly 100 million neutrons passing through. Although there are so many neutrons in close contact with us, these particles are very secretive and unwilling to reveal their traces. We can't feel their existence. So neutrons are called cosmic ghosts. But they still play the core role. They not only help to build stars and galaxies, but also indirectly create some basic elements in the material world we live in. Everything can be seen and touched. But many scientists generally believe that in the origin and evolution of the universe, there used to be a material world and an antimaterial world. But the antimaterial world disappeared later. After many years of research, many scientists believe that neutrons, which widely exist in the material world, may contain important information in the antimaterial world. So studying neutrons becomes extremely important. So how were neutrons discovered? In the late 19th century, researchers observed a strange phenomenon according to the law of conservation of energy and conservation of momentum. When neutrons fluctuate into a quark and an electron, the energy of the electron should be the energy difference between the neutrons and the quarks. But the actual measured electron energy is smaller than the predicted energy. This means that some of the energy disappeared for no reason. To explain this phenomenon, a physicist Pauli proposed an assumption in 1930 that after neutrons fluctuate, in addition to quarks and electrons, a third electron is also produced. This electron will also fly out of the atomic box, just to carry the energy and momentum that disappeared. This electron is a new type of electron that does not have a quark or is of very low quality. It is classified as 1 in 2. It can ensure the conservation of energy and momentum in the beta fluctuation. In 1934, the father of nuclear reactions, Fermi, named this new type of electron as quark. Although theoretical physicists have long predicted the existence of quarks, it took scientists 26 years to finally find its existence. In 1956, physicists Reynolds and Cowan led a research team to detect the electromagnetic antiquark produced by nuclear reactions and finally observed the evidence of quark existence. This year is also known as the Quark Year. Currently, China is accelerating the construction of the 700-meter low Jiangmen Quark Laboratory, which will also start scientific research at the end of this year. After completion, it will be the world's most advanced high-energy physical experiment device. It is expected to test the quality of quarks for the first time, and the completion of 3 types of quark quake parameters will also reach an unprecedented 1% progress.